Hello friend, oxypene. You know the heterocycle compound contains 7-member ring. Oxygen is heteroatom, unsaturated. It exists in equilibrium with the bicyclic tautomer benzene oxide, and both tautomers present at room temperature. So Vogel and co-workers synthesized the oxypene. Now synthesis from cyclohexadiene. Oxypene can be synthesized from 1,5-cyclohexadiene by epoxidation, addition of bromine, and tetrahydrobromination. Yield is 80%. Cyclohexadiene treated with this peroxide, it gave 1,2-epoxy cyclohexene, and further treated with molecular bromine 1,2-epoxy 4-dimethoxycyclohexane, and reflux with the sodium alkoxide ether, you will get this oxide, and which is on equilibrium with this oxypene. So substitute oxypene can be synthesized as above method from appropriate cyclohexaone-4-diene by epoxidation, addition of bromine, and dehydrobromination. You can see this compound treated with peroxide, it gave epoxide. Further treatment with the molecular bromine, it gave 1,2-epoxy 4,5-dibromocyclohexane. Further treatment with sodium ethoxide and ether, it gave epoxide, which on equilibrium with the 2-methyl oxypene. Now the second method from substituted furan, 2,4-disubstitute furan treated with dicarboxymethoxy acetylene in presence of light and iodine till cell radiation produces 7-oxaquadricyclane. 7-oxaquadricyclanes rearrange into oxypene by heating actions. Now from valence bond isomerization. You know, on pyrolysis 1,2-divinyl ethylene carbonate in the presence of lithium chloride at 200 degrees Celsius is transformed into a mixture of trans-divinyl ethylene oxide and cis-divinyl ethylene oxide. Both cis and trans form of divinyl ethylene oxide rearrange to the valence bond tautomer, that is 4,5-dihydroxypene. So 1,2-divinyl ethylene carbonate treated with pyrolysis, it gives cis-divinyl ethylene oxide and trans-divinyl ethylene oxide. Valence bond isomerization, it gives 4,5-dihydroxypene. Now from dibarbenzene, you know, by the epoxidation of dibarbenzene with metachlorobenzoic acid in presence of dichloromethane yields structure 1. Dibarbenzene oxide, which on photolysis or pyrolysis give oxypene. So you can see the synthesis of oxypene. Now chemical reaction. Photochemical reaction, oxypene in the presence of light is converted into 3-oxabicyclo 3,2,0 hepta 3,6-diene. You can see the product. Diels-Alder reaction. Oxypene react with the malic anhydride to give ETAC. Oxypene readily undergoes Diels-Alder reaction. Reaction with acid. In presence of acid or heat, oxypene convert into phenol. So both isomers of oxypene, that is benzene oxide and oxypene, exist in equilibrium. The equilibrium shift toward the benzene oxide at low temperature and in polar salt. The position of substituents and nature of substituents affect the equilibrium, benzene and oxide of oxypene. Now, two substituted, especially by conjugative electron withdrawing groups, favor the oxypene form. In 2-acetyl oxypene form is stabilized by resonance because of conjugative interaction. In 3-acetyl oxypene benzene oxide form is resonance stabilized. You can see conjugative interaction in 2-acetyl oxypene. It is in equilibrium with the oxypene tautomers, and 3-acetyl oxypene. You can see 3-acetyl oxypene and epoxide benzene oxide tautomers.